Hello, everyone. That is too big. Yeah, there we go. Hi, everyone. How's it going? Welcome to day one, and depending on time zone, day two of GHW. Hopefully, you are all enjoying what's been happening so far. So, welcome to, I would still say, day one of GHW. And I am UT. I prefer to go by UT. My name is Utkarsh, and I am a coach at Major League Hacking. I am here today to actually talk about SQL. Okay, something that we kind of end up using nearly every day, right? And I say nearly because at some point in data week, you have to work with data, which you might already have. I think yesterday we had a session of Snowflake, right, which was working with data. And so you are interacting with database, and at some point definitely you would interact with a SQL database, a, a SQL-like database. Then you'll interact with no SQL database, and you'll wonder, interesting, how do these things work? How does a database exactly work? Where does a database actually store its data? Does it use another database to store its data? How do these things work? Now, these were the questions that I was asked, and I was like, this is interesting. So let me do some research on it. So I did some research, I found some answers, and I was like, you know what would be fun? Actually taking a session on this in the next Global Hack Week. And here I am in the Data Week taking a session on how to build your own database. And this would be a very raw JavaScript implementation of the database. But at the same time, we'll learn a few concepts. We will actually practice some SQL syntax on a very famous website called as SQLBolt. Okay, the link to which I will share in a minute. So we will learn some real SQL syntax on SQLBolt. We will write some code on our for a JavaScript implementation of SQL database, I would say, and we'll publish it as a library. And at the end of it, we would have, I would say, a better knowledge of how do these things work under the hood. Okay. So I hope you're all ready for this journey because this is going to be exciting. This is going to be more programming than any of my previous sessions. So in my previous sessions, anyone who has been a part of my previous sessions, they know that I have this very famous phrase of uh, this is basic, but if you stay around, help others, you will learn, they will learn, everyone will learn. Uh, but as part of the today's session, which is a 4-part stream. This is part one. And then we have part two right after this, no breaks in between. I give you like 10 minutes break. So we have part two right after this. So part one, part two. And this would be kind of programming heavy. I would try to make it simple as much as possible from my end, frankly. But if there are some things that you don't understand, feel free to make a note, skip through it, and then learn it later. Okay. Library means a JS library or a SQL library, a JS library. That's why I said a JavaScript implementation of SQL is what I'm aiming for. Okay, so uh, I think I can wait for maybe let's say a couple of minutes. Let me set some background music so that anytime you hear the session in the future, you're just not bored with my voice. Okay, perfect. I think that's good for now. Uh, okay, so before we begin, a very humble request to please register for the session. The link to the registration is now in the chat. Okay, so please register for the session. helps you, helps me, helps MLH keep track of how many people are actually interested, right? So please register for the session if you have just joined. And if you, yeah, I think if you don't have any issues, let's get started. Anyone who's just joined, also, you're welcome. Uh, and a very big hi to you for joining. And you're taking a big step. You're taking a big step in learning SQL. Okay. So without any further ado, let's get started. Now, things that you have to take a note of. Uh, Step one, please register again. Step two, uh, open this website, which I am sharing in the chat, SQLBolt. This is one where we'll use to quickly learn SQL, okay, very simply. And once we learn some theory, so the way this session is structured, this and the next three sessions, okay, is structured is we'll learn some theory, we'll practice it on SQLBolt, and then we'll try to create a JavaScript implementation of it. I will keep coming and going off the screen depending on when you have to focus on code versus when you have to focus on my hand gestures. Okay. So that you can, yeah, you don't have to look at me every time you're writing code. So, yeah, depending on that, we will keep switching. And if you have any questions at any point, please put them in the chat. And as soon as I, like, get some time being like in every 5 minutes or so, I'll keep checking the chat for any questions that are arising and try to answer them to the best of my knowledge. I'm not like a genius or something who knows everything, so I'll try to answer your questions satisfactorily, or we can Google search them together. Okay, that's also an option. Okay, cool. uh, let's get started. So step one is some theory, right? So the first theory is for people who are very new to this whole programming, computer science domain. Now, this is some basics that we start with. What is database? Okay, that's the first question you might have. What are these databases? What is he talking about? So you can think of databases as an example, as if you have to see this on a PowerPoint presentation, someone would define a database as structured data storage. Okay, you're saving the data into some particular structure. You're following some particular structure to store the data. And why? Because then in the future, it helps in efficient data access and management of data. Okay. So when we save something in database, we save it there for a reason. Like if I have to save the names of all the books that I have read, I have two options. I can save them in a file, a text file, or I can save them in a database. The difference is that if I save them in a file and if I make multiple files over the time, depending on books I read in 2023, books I read in 2024, books I am going to read in 2025, books I've read in 2019, 2020, so all those, you get an idea. I in my mind, I have categorized them in some form of structure. But tomorrow, if someone asks me, wait, when did you read the Da Vinci Code by Dan Brown? I'm like, wait, let me go through every file that I've created, do a quick Command F or Control F for a search, and see when did I read it. And if I don't find it, like I start from the first one, which is the books I read in 2019. I start from there. And what if I read that book in 2024? I would have scanned through so many files without any reason, right? Now, if I would have done this in a database and I would have just queried or asked my database, tell me when did I read the Da Vinci Code, it would instantly kind of return me the answer. Okay. When I read that book, when I might have added that book to the database, all those things, depending on what have you entered in your database, it will return that to me nearly instantly. And that is the difference of uh, using database versus using files to store your database. Now, interestingly, Okay, which I'll come to later. Uh, we'll talk about where does a database store data. Okay, now what about the types of databases? You have SQL databases, the one that I keep saying right now. So, what is a SQL database? SQL is more like a language, a structured yes, query language. Yeah, structured query language. And SQL databases are the databases which kind of adhere to this query language. Okay, so they are mostly relational database management systems, and they have a relational model. What does that mean? It means that they look more like Excel or Google Sheets, which is they have rows, sorry, and they have columns. Okay, they have columns and they have rows, and that is why we say that there is a relation between what is there in the row here versus there in the column here. So this row, this column, there is some relation between those two things. And some example of SQL databases are MySQL, PostgreSQL, SQLite. Okay, then you have something called as NoSQL databases. NoSQL also is one of the terms for it. Now, these are uh, non-relational database. And when we say non-relational, uh, we also say that these are more like a document type database. When I say a document, think of it as a file, okay? Another way to think of it is JSON. So you know what a JSON looks like, right? There is a key, there is a value. You can quickly search for JSON structure. Okay, so you can think of, so this is the name is the key, John here is the value, age is the key, 30 is the value, car is a key, null is a value. So key value structure. And most of your NoSQL databases kind of, and I say most, kind of like this. They are more of a key value structure. Now, if you have to think of this key value structure in terms of SQL rows and columns, so you can say that this is your column. So the column name is name, the column name here is age, the column name here is car for some reason, and the row values are John, 30, and null. Okay, so I hope that gives you a sense of, okay, NoSQL can be pivoted to become SQL in a way. So that is your NoSQL, and these are more like document databases. Okay, examples include MongoDB, Cassandra, and even kind of Redis. Uh, then you also have this new age things called as new SQL database. So new SQL database, they combine the scalability of NoSQL with the properties of SQL, which is ACID. One of the major properties of SQL is ACID. Okay, which the full form of ACID is atomicity, consistency, isolation, durability. Okay, uh, we'll get into it a bit later about what these terms mean. But you have new SQL, which is combining NoSQL with the properties of SQL, which is ACID compliance, and the examples include CockroachDB, Google Spanner. Okay, then you have in-memory databases. So in-memory databases are, you can think of them as the data is stored on a RAM. Okay, uh, because the easiest and the fastest way to access something is to store it on your RAM. Okay, so on the RAM of your computer, you are storing some data for very high speed processing, and these are in memory databases. One of the very popular ones is Redis, the other is Memcached. Okay, then you have something called as time series databases, which are optimized for any stamped data. Example, financial records. You make a transaction, you make a banking transaction, you GPay someone, you if you're coming from Europe, you definitely know about Revolut. So you send money via Revolut, and all these transactions are stored somewhere in some database, right? And to go through that database, you can say that the timestamp is something which is very important for every person there. Like, when did I do this transaction? So for you have time series databases, which are very much optimized, that anything that has timestamp goes there, and it's very fast to access and stuff. Some of the examples include InfluxDB and TimescaleDB. Okay, where DB is database. Uh, and then you have graph databases, which are very good at handling interconnectivity. Examples include Neo4j and I think Amazon Neptune. Okay, so what is GraphDB? Uh, I think one of the best ways to visualize a GraphDB is think of Facebook. Okay, I know no one uses it, but you certainly have heard of it. Okay, I'm joking that no one uses it. I use it. Uh, anyways, uh, so the graphing. Okay, you as a person, you are, let's say, at the center of this graph, and then my mom is on Facebook, my sister is on Facebook, my dad is on Facebook, my uncles are on Facebook, and slowly, if you have to form connections, so there is one line that goes to my mom, okay, connects me to my mom. My mom is connected to my dad, okay, on Facebook. So my dad would should be connected to me, is what Facebook would think of, and then give me as a suggestion that, you can connect to this person. Okay, it doesn't know it's my dad, but it would tell me that these are some people which I think you should be connected to. And the way it's doing is it's forming kind of a relation between us. Okay, so that's one way to think of graphs. And oh yeah, very good suggestion, mutual friends. Okay, mutual friends, think of that as also a graph. I have a connection with someone, they have connection with someone else, and Instagram or someone, Snapchat, I don't know which other apps are there, uh, suggest that you can kind of have a mutual connection with this person. LinkedIn, okay, LinkedIn mutual connections. Your first connection, your second connection, your third connection. You're kind of forming a relation between these people, and it is more like, you can think of it as more graphically oriented. So that are graph databases. Now, one of the key differences between like SQL and NoSQL is the data structure, which is relational, flexible, and the ACID property of SQL. And NoSQL is more for unstructured data. When, like, let's say you're building a new project, you're not sure how exactly or which exact columns you will have. So you start with more of a JSON format, okay, no, more of a NoSQL format. And once you have gone through, like, let's say 1000, 10,000, 1000 is too less nowadays. You have gone through like 10,000 iterations of things. You have 10,000 data, 10,000 JSON objects. And if you start seeing a pattern there, that's when you would think of converting it from the NoSQL to a SQL. And that also depends if you want to. Okay. And I have some resources for you. Also, some real world applications. Where would you use SQL? Banking system, e-commerce platforms, uh, and NoSQL would be more like IoT related stuff. Uh, Maybe some old data which needs to be typed in sometimes would go into NoSQL because you don't have a structure yet. Uh, any new project that you're starting, definitely you'll go for a NoSQL one. Now, I have some links for you all if you want to learn further about these stuff. So there is this link, which is what is a database. Okay, some more details on that. Uh, MongoDB, which is a NoSQL database, explains it in more depth. What is NoSQL versus SQL? Then you have even IBM actually explaining it. So that link goes in the chat as well. And if you want to learn SQL, then one of the very good resources would be an academy. Okay, so some resources for you all. I think this is one going to be my one of the streams where I share a ton of resources in the chat. So anyone who's watching it later on YouTube, you'll still find those resources there. Okay, uh, because all these sessions are recorded. Okay, now enough about SQL, no SQL. The reason why I actually, uh, started this session or thought of this session was this question: what exactly does a database use to store its data? And one of the most popular and very easy configurable, I would say, database is SQLite. So what is SQLite? It is a self-contained uh, and serverless. Okay, you don't have to host it somewhere, and zero configuration SQL database engine. So I think most of the programming uh, frameworks, I would say, example Python or even in Node.js, you have, excuse me, sorry, you have a way to add a SQL database. Okay, even in Java, first, as far as I know, that you can add SQL database as kind of a library, as a dependency, and interact with it. So you don't really have to host it somewhere on a separate server, connect to it or something. Uh, you can just do it locally. And that is one of the very good things of SQLite. Everyone has a database. Now, some historical background, it was created in year 2000. So it is actually younger than me, but still one of the most deployed database engines. Okay. So if you compare it with any other thing, SQLite is nearly everywhere. It was created by D. Richard Hip, uh, as I said, in 2000. And who uses it? Most of the mobile apps, Android or iOS, okay, alike, use SQLite. Browsers use it. IoT devices use it. And they actually have a page on who uses these database. Uh, Wait, let me share that. And as per their website, it is used by Adobe, Apple, Microsoft, NASA. Okay, so I would say far reaching effects of SQLite. And why? Because not interestingly, very conveniently, it is lightweight and portable. It is a single database file in the extension of .db, okay, for the entire system, and single database file for everything. Okay, there's zero configuration kind of. All you need to do is install the library, and then uh, basically I would say, uh, yeah, kind of connect to it. That's it actually. And cross platform compatibility, which is, you don't have to worry about if it works on uh, Linux, will it work on Windows? It will. It will most of the times, unless there's something about the path that needs to change. Everything else should work fine. And it's simple to use, of course. Good for very small projects. Not very small, I would say small projects. So you can store up to like 100,000 rows. So 1 lakh slash 100,000 rows uh, very easily without any performance issues. Uh, and it is very ideal specifically for embedded systems where you need something very lightweight to quickly store data. Okay, now the resources that we will refer to maybe during our course is their documentation. So there you go, their documentation. uh, and a very interesting one, which is, when do you use uh, when do you use SQLite? and they give you a very comprehensive, uh, I would say, notes on when should you use it, when do you use it, like, and they give you examples like embedded devices and IoT. SQLite works very well on websites where you have around 100K hits per day. Okay, you can have SQLite for it. For even data analysis, you can kind of, uh, if you have Python, you are reading some from very large files and you want to save it in a database for quick reads, you can use SQLite there. uh, Caching, one of the very good things is that you have a very big database somewhere and you want to create a small duplicate of it with the recent things that have been searched. Okay, so let's say the books example, I'm storing it in another database. I'm storing it in, let's say, MySQL, and I don't want to touch MySQL every now and then because most of the times there are only these famous books that people ask me, have you read this famous book, have you read that famous book? So for the first time I query my MySQL database, I get the data and then I store it in SQLite. Okay. Next time someone asks, I query my database. Okay. And I say database, it goes into and searches first in my SQLite. If it's there, good. If it's not there, then it goes and harasses my MySQL database. So yeah, you can use it as a cache per se. And yeah, so those are some good examples of when to use SQLite database. Now, give me 1 second. I feel like I have a cough. I need to drink some water. Okay, I'm back. Sorry about that. Uh, okay, so I think that was a good introduction of SQLite and in general SQL, NoSQL, in-memory databases, basically databases. So we learned about what is a database. We learned specifically about SQLite database because that is actually our uh, introduction to the library that we are going to build. It is more of a motivation uh, for us. And the first concept that I kept talking about is, where is database data stored? Okay, where is anyone storing these data of the database? So SQL uh, normally stores data in dedicated server files. Okay, so you have, like, think of it on another computer somewhere. You have this mysql.exe. Okay, an application file, or I think in Mac it would be .dmg. So you have basically mysql application, okay, as an app running somewhere, and then from your computer, which I'm like sitting here, I will kind of try and connect to that computer via an IP address and go to a particular port of that, and that gives me access to the MySQL database. I can do that, do the same on my computer as well. So I can run MySQL database as an application. It opens up a port. Okay, and then I can connect to that port on my computer as well. So that is your normally where you are connecting to database, and the database itself now on that computer, whichever computer that is, mine or somewhere far around, far away, it will actually save every data that I give it in files. Now, in case of SQL, it stores everything in a single database file, and it is called as it has the extension of .db. Uh, and if you actually want to share your database with anyone, you can just copy paste that .db file, zip it, and send it via email or any way you like for them to receive all your data. Now, what are the file formats? For flat file systems, it is more of a JSON or CSV format. And in SQLite's case, it is the .db one is more of a binary files. So you don't really read it as quickly. Uh, like by just opening it, you would still need to use the library, which will kind of convert that binary data that is inside it and show it to you in a nicer uh, whatever language you have stored the data in. And what the problems that come with data storage and specifically with SQLite is managing consistency, the concurrency, and indexing in multi-user environments. What does that mean is locally it's fine if you're building it for your own project, but let's say you added this SQLite on a separate server, you're running it somehow, and then 20 people are trying to access the database at the same time or trying to add data at the same time. It kind of like 20 is very less number, but assuming that let's say SQLite was not able to handle it, the consistency becomes a problem. Like the data that you are entering and the data that I am entering, we are trying to enter it at exact same time. Whose data will get added? Okay. When you have more data, searching through the data becomes a problem, and so these are some of the issues that you know comes with data storage. Okay, let me go through the questions. Okay, that's done. I've seen somewhere it stores in memory. What is this about? uh, Good question. So we actually talked about in-memory databases where the data is actually stored on your RAM, okay, on a computer's RAM, let's say, for easy access, for quick access, and uh, that is what is actually called as caching. Okay, okay, the so that was all about where is the database data stored in files. Okay, very simply, it is stored on files. The next thing that we need to learn about is the tables. Okay, so what is a table? Now we forget everything about NoSQL or anything for now. We focus only on SQL. And one of the fundamental things, or one of the fundamental building blocks, I would say, of relational database is tables, because it helps you organize the data in rows and columns. You can also call the columns as fields and the rows as the records. And to create a table in SQLite, you have a very good syntax, which is like create table, the name of the table, then actually let me write it somewhere. Okay, so the syntax is create table, then name of the table, which let's say in our case is users, and then you can define which fields are there. Okay, so when I say fields, I mean the columns, right? So the field is, let's say, ID. What is the type of the field? It is going to be numbers, so we will say it is integer. Okay, and then you can define more fields. Let's say name, which is going to be of text. Okay, it's going to be string. Then age, which is going to be integer, right? So creating tables in SQLite, this is the format that you would kind of follow. And these integer, text, and integer, these are what you call as schema validation. Okay, when someone stores the data in this column or in this field, what kind of data do you want? Do you want to enforce any data integrity? Like someone can store numbers, but if you don't define it, someone would want to store text there. Someone would want to store URLs, which is kind of a text only. But let's say, supposedly, if it was different, someone might want to try and store some boolean, which is true or false there. So and assuming that you have not defined this, they could try and do that. But for enforcing the data integrity, you want to actually store data which adheres to a particular schema. So that is where this integer text integer comes from. You can also define some other things like primary keys. Okay. So when you define this primary key uh, in SQL language, what it means is that this needs to be unique. None of the rows or the records can have the same ID. They have to be different. Similarly, so this is also a constraint, you can say. Another constraint can be that the name is not null, is another constraint. So what does this mean is that the name cannot be empty. Everyone is supposed to have a name. It's okay if they don't have an age defined, but the name has to be defined, is what this line means. So this is actually a simple SQL syntax that we have learned very quickly. And now we are going to practice it. Okay. Also, I don't like the left and right here, so I'm going to move this. Okay. So now let's practice this SQL on SQLBolt. Any questions before we start practicing? I'll share the link to SQLBolt again in the chat. Please do open it. And what are we going to do is we are going to learn how to practice it in a more interactive way. Before we start building our own database, let's practice some SQL. Okay, I think that's enough time for anyone to open the website. There's no login or anything required, so that is really cool. Okay, let's start. So begin lesson 1, writing queries. And oh, this actually starts with select, which we haven't learned. So let's learn that as well. Uh, okay, but before that, we actually have to learn about how to insert data. Let's take it slow. Sorry about this. So the first thing that we learned is how to create a table. A table is more like, and I'll tell you to visualize this in Excel/Google Sheet, which is that a table is kind of like creating a new sheet. So this is an example of a new Google Sheet or a new Excel file. Okay, that is the table. Then that's what we have learned till now, how to create a new Google Sheet or a new Excel file. The next thing that we want to learn, which is very important, is how to actually add data in this file, right? So let's learn that, how to insert the data in these files. So this is the first concept that we had, was where is the data stored. The second concept that we learned is about tables. And the third concept that we are going to learn is about inserting data. Also, for you to visualize it quickly, this ID, title, director, year, length, minutes, these are our column names, or you can say our fields. And this one, Toy Story, something, something, two, A Bug's Life, something, something. These are our rows or records. Okay. So now to insert data, the syntax is very, very simple, I would say. It is into, insert into which table, which is the users table. What do you want to insert? I want to insert the ID, the name, the age in this order. Okay. So this is very important. What I'm saying here is that I want to insert this data into my database in this particular order. And then what are the values that you want to enter? 1, Alice, 30. So this is how you would insert data into a SQL database, specifically in SQLite. Now, what happens internally is that once you take this, you write this query, okay, that's the term here. You write this query on either in your programming language, command line, however you are accessing the SQLite database, it parses the query, it reads the query, tries to read that whole string that you have written, understand what you want to do, and then appends these rows in the .db file. The problems here that can happen, that can occur, is number one, schema mismatch. Okay, like you tried to add ID, name, and age, but you said that okay, I'm going to actually miss this. Name is supposed to be not null, it is null right now. So what happens then? uh, Age is integer, you tried to add it as a string. So schema mismatch is one of the errors or problems that could occur. Second is duplication of keys. Of course, that is also, you can say, kind of a schema mismatch. uh, that it's supposed to be primary key, which makes it unique, but you try to kind of repeat it again, and you change the name here but did not change the ID. So again, duplicate keys, challenge of insertion. So, but for the time being, we will learn that this is all we need to learn. Creating a table, inserting into the table, the syntax for both of them. Let me also add some kind of comments, I would say. One of the major problems that could occur is you try to insert into a table that does not exist. So instead of users, you go like, oh, I think my table was called my users. That's also a problem, right? uh, because this table will not be found. It's like adding to a Excel file which does not exist, which is just impossible. Okay, now once you have inserted the data, and this is where the fun starts occurring, because most of the times you will find that someone else has already inserted the data, and your work will kind of be around querying the data from the tables. Okay, querying the data, which is like selecting specific data and getting back the results. Now that is something I think we can practice definitely on SQLBolt. So coming back, hopefully you have uh, opened this already. So the first lesson in this is select queries, and it is actually the fourth concept for us, which is what is select. Okay, selecting data. So to select data, it's like querying the data from the tables. As I said, you want to go to the table, you want to go to the table that you have created, and you want to say, return me some fields. Okay, data of some fields. Okay, so the field being the column names. So you will say, like in our case, you will say that return me all the IDs in the tables. So uh, that is what is selecting or querying the data means. Now the syntax to select data is very simple. It is select, and then the fields that you want, which is in our case, let's say I want the name and the age. From, okay, then you define which table do you want it from. It doesn't know the table yet, so then you define the table name, which is users. Okay, and this is how you can select the data. And let's say you only want to select one thing, so you do go for select name from users. You want to select multiple things, you can add a comma and add fields. What happens if you try to select something that does not exist, like date of birth or DOB, let's say in this case? What happens then? It's supposed to give you error, right? Or some format of error saying that you're trying to get data from a column or a field that does not exist in the table. So please don't do that. Let's try it on SQL Bolt. So going to this link, which hopefully you all have open, uh, let's look at our exercise. The first task here is find the title of each film. So I can do select title from movies. Movies was the database. Okay, movies was the table. Sorry. Uh, so there we go. So we have completed the first task successfully. Second is find the director. So I can go for director. Second task completed successfully. Okay. Also notice the lowercase. What happens if I actually do or let's say title? It works. Okay. So you can think of, at least on this website, it is more of case insensitive. Uh, and I think I would say uh, there are a few databases where the column names are supposedly case insensitive. So all caps, all small, doesn't matter. Now, title and director. So title, comma, director. That gives us this. Find the title and year of each film. So I can do title, comma, year, and that's done. And then this special syntax of find all the information about each film. And to do that, you do a star, which is finding all the information. So one of like this is again a special syntax. So in our case, if we want everything from this users table, I can do like select star from users. Also, this doesn't have to be capital. Again, SQL does not differentiate between things being capital or small in the query itself. Uh, but this is more like for your understanding, like which one of it is actually a syntax and which is more like the name of the table or the name of the field or something. Okay, so for your understanding, uh, yeah, I think that is good enough for now. Let's actually start building something. Okay, start building the whole mini SQL DB library. Okay, so we have learned like creating a table, inserting into a table, selecting from the data, and we have also practiced that on SQLBolt. Now what we will do is we will actually create a project which will take, I would say, around half an hour, because we have to do some initial stuff, and then we will write some functions to insert to create a database, insert into the database, and select the database. So I would say this is more like the whole of the session gone. Okay, so how do we do that? Step one, I would request if you have VS Code, that is well and good, uh, because that is the text editor that I'm going to use. So please have VS Code. Also, let me change this into light theme. I have my things switched on. I have my lights switched on, but for some reason, it's not bright enough. Feels so. Okay, yeah, this is the first time I'm going for a light theme, just so that there's more light on my face when I am on the screen. Uh, okay, too bright. I feel for the screen. But anyways, focusing on what's at hand here, we want to focus on you seeing everything as well as seeing me when I'm on the screen. I will soon go away. Anyways, coming back. So hopefully you have VS Code installed, which is the text editor that I'm going to use, and you need to have Node.js installed, because the whole project would be more of a Node.js syntax project. Okay. Uh, and we'll use Node to actually run every file. Okay, every JavaScript file, we will use Node to run that. So you need to have Node.js installed. You need to have, if you install Node.js version 18 or more, you will already have npm installed. And once you have Node and npm installed, uh, and a text editor installed, you're good to go. That's where we start. So I've already created a folder which is called as mini-SQL DB. This is the name of my folder, and that's it. And I created just example text to show you the format of the syntaxes. for SQL, but that's it. So all I want you to do is create a folder, open it in VS Code. I'm not going to go into details of how to do all that. And then on the terminal, this is where we will start doing stuff. Uh, okay. So step one is to actually create a npm package here. Okay, make this a npm library per se, and the way to do that is you could do npm init and hit enter, or you can do npm init dash y and hit enter. Also, tell me if everything is visible. If someone can kind of tell me that you are able to read everything that I'm writing, that would be helpful. Okay, I'll take the silence as golden and assume that you can read everything that I'm writing on my text editor. So npm init dash y, what does this command do? It is saying that initialize this folder as a node project, and take the defaults. The dash y is basically saying yes to all the questions that it is going to ask. Uh, or if you want to actually take a look at the questions, I can do npm init and hit enter. And now you can see the questions. The first one is package name. Should it be mini-SQL DB? I would say no, actually make it at the rate UTK, because that's in one of our previous sessions, not the last one, maybe a year back or at least 6 months back, we actually created a npm JS account for one of our projects whose username I think was this. Okay, actually, let me confirm that. 1 second, sorry. Authenticator. I need to authenticate myself. Two-step verification is nice, but it also takes a time when you have to do it urgently. Yep. So it was this. So I'm going to name my package as my username slash mini dash SQL dash DB. You can add your username or you can go with whatever is the default. Now hit enter. This is version 1.0.0. Yes, hit enter. Description, not really required. I can hit enter and skip this. But in our case, I will give it some. Light weight file based SQL database in JavaScript. I think this is a good description. What is going to be the entry point or the main for this? It would be index.js. I'm going to take this as default. Test command, I am not going to add any. The Git repository, I can ignore that for the time being. The keywords, I can actually add some if we want, but I'm going to ignore that for the time being. The author, uh, that would be my other GitHub account where all of my previous MLH codes are there, which is this one. The license, I'm going for MIT. And is this okay? So this is what will be created in a file called as package.json. Okay, so in package.json, this is what is going to be created. And it looks okay. So I'm going to say yes, and that's it. And there we go. There is our package JSON created. Okay, so for anyone who's joining right now, uh, just to give you a very quick recap, we are starting to build our uh, project. And this is the first thing that we did was create a package JSON. And I'd say, yeah, this is good enough, right? Now, in any project that I actually build, I actually start, I kind of set up a few things. So let's start with that. Okay, very quickly. The first thing is a new file which will be called as eslint.config.js. Yeah, we'll fix that. eslint.config.js. This will have actually all the configurations that I would like. So I'm going to actually add the name of the file on top, eslint.config.js. This will have all the stuff, all the configuration which I want my linter to handle. So you can think of it as kind of a code helper which tells you, oh, you can't do this, you can't do that, this is a bad idea, uh, stuff like that. Okay. And interestingly, we will also use this to also make our code pretty by using prettier. We'll install prettier as well, which will help us make this more pretty, which is to ensure that the same syntax is followed across. So I push this project on GitHub. You clone the repository, and then you try to install the stuff and do things. uh, it should not give you errors, right? So to ensure that the formatting of my editor, my text editor, and your text editor is the same, that is why we'll install Prettier. And to ensure that we kind of catch a few bugs early on, and also try and ensure that there is a common structure across, we'll use the linter. So we'll create something here. We first need to install a bunch of things. Uh, Another file that I'm going to create is .npmrc. If you have been to my previous sessions, then you know I'm a very big fan of save exact. Okay. So what does this mean? Whenever you install a library, it tries to install it with that caret symbol or a tilde symbol, which is the other way of saying that we will update the library every time you run the npm install command, depending on if there is a newer version. I don't like that. I want to have the exact version always, which is why I always go for the save exact true. It helps in debugging later. Like tomorrow, if you upgrade a library and your website breaks, your code breaks, something happens, you know that it's probably the library upgrade that caused the issue, and you can kind of revert back to a previous version, which I really love. Uh, what else? I think the next would be Prettier RC. This is where we'll add some code for prettifying stuff. And what else? The entry point, as defined in our main, is index.js. So let me add that as a file. This would be our entry point. So I'm going to call it index.js. Uh, Let me also add a very quickly a readme.md. Now this is about the project. Okay. So mini-SQL DB. And I'm going to copy paste the description that I already had. So a file based SQL database and stuff. Uh, what will be our folder structure? We'll have our mini SQL DB at the top, of course. And then we will have a lib folder here. Inside that, we will have some stuff. Actually, I can leave that for the time being. We'll have lib folder with some stuff which we'll put in later. uh, then we will have once all the things in the lib are done, we will actually put in, we actually have this index.js, right? Okay. We have our package JSON right here, and we have our readme right here. Okay, so this is going to be a folder structure kind of, uh, for your later reference. You don't have to copy paste all this. I'm going to push it on my GitHub, and you can easily access it from there. Okay, very quickly. I'm just adding a few files and adding some syntaxes, which I have kind of already created. But I'm doing this to give you an overview of things that you definitely need. Since this is going to be a Git, going to be on GitHub, and this is going to be a Git project, I'm going to add a git ignore. This will have all the files and folders that it needs to ignore. One of the major folders would be node modules, which I'll show you later. We'll also create a .env file, which is supposed to be ignored because this is where our secret stuff is going to be stored. Okay, so that is one of the things, and I think this should be good enough for now. This example.txt, uh, let me rename that to SQL syntax.txt, uh, and we can kind of ignore that, but for the timing I'll actually add that. So I would say it comes right after the readme. Okay, now let me quickly run the first command. The first command that we are going to run is to install some libraries. Now, which libraries are we uh, going to install? We'll install multiple over the time, but let's start with some basic, which would be npm install a dev dependency. Okay, so right now what you see here is something very like name, version, description, but we don't have a dependency or a dev dependency. So let's start with that. The first one would be eslint/js. The other would be eslint. The other would be, so I'm adding a space in between, eslint-config dash prettier. Then there would be eslint dash plugin dash prettier, and there is globals. Okay, so these are all the libraries that we need to install, and I'm going to hit enter on this. It should do the magic, and it should install, it should create this dev dependencies and install all these libraries without any caret or anything. And this creates this node modules folder, which I'm pretty sure I did not install human fs, Acon JX, AJV, and all these libraries. These are all like a sub dependency of the libraries that we installed. Okay, and this is massive. But anytime you have a package JSON and you have a package lock.json, you can create these node modules by just doing the npm install. So that is why we are going to ignore this. We will not push this on GitHub because it's not needed. Okay. Uh, what else? I think this is good enough. Uh, Git ignore. Let me actually add a bunch of more stuff there. And I'm going to copy paste that. And this would be for your, I'll explain it to you. So for operating system, so for Mac OS, sometimes it creates these two files and pushes them on GitHub. I don't want that. From IDE perspective or text editor perspective, if you have some special configuration for your VS Code, We don't want to push that. So .vs code is going to be ignored. .idea, if you're using IntelliJ IDEA for coding, that we want to ignore. The env files, which are environment variables, which are more like our secret files. If you are new to this, we don't want to push our secret files on GitHub for everyone to see. So that is why they are going to be ignored. This is something that we will create going further. So that is why I've already ignored it. We'll create a folder called as database and a backup, and they are automatically going to be ignored by for pushing. And same for any logs folder that we create probably in the future. That's done. What about prettier RC? Now this is the configuration that I normally go with, and I will copy paste that quickly. Sorry. So the configuration that I normally go with is number one is semicolons, true. Okay. Single quote false. I like double quotes. Trailing comma everywhere. Excuse me again. Sorry. Sorry. I think I've got a touch of cold. Okay. Then the next one is print width, which is like how many characters in one line. Tab width would be 2. Use tabs false. Use spaces always. Bracket spacing 2. Arrow parents is always, which means always have arrow parentheses in the next, like if you're using arrow functions, add brackets around. And end of line lf, which is also something that you will see right here at the bottom of my text editor. So that's something that I'm copying pasting. ESLint config, let me quickly copy paste that as well. Like basically this is one of the things that I always use. And I've also added some notes about what it is for. So let me copy paste that as well. Sorry, the setup is taking some time, but I want you to go through it just so that you understand exactly. And if you have to do this in your future projects, what do you need to follow? What's the structure that you need to follow? Feels too big to me. Okay. So just importing a bunch of things that we actually installed, and this is this actual configuration. So the first one is about which files to ignore from ESLint or linting. Like we don't care about what's the problem in these files and folders, which is node modules, database, uh, backup. These are the folders that we have added in git ignore, prettier RC as well. Then which files do we want to actually check, which is, I'm saying, go nested into .js files and check the syntax of those. The ECMA version, or more like the language version, which version do you support? I support up to ES 2022 features. I'm also setting the source type to be module to enable import and export syntax. The globals is to actually allow all the properties of Node.js. The plugin that we are using is Prettier for prettifying everything. Some rules that we want to enforce, I would say. One is all the recommended rules of the base JS or the base JavaScript of ESLint. We then ESLint and Prettier, they kind of at some point do the same thing. We want to disable Prettier from doing the same thing as ESLint. So that is why we are disabling anything that conflicts with Prettier. Sorry, I said the other way around. Yeah. Then you have no console off. So I'm basically, because during the project, I'm going to write a lot of console.log statements, and that normally would give, like, should give an error if you're making a production project, whatever. But in my case, I'm going to say allow that because this is just for us. Then for equality, instead of using double equals, go for triple. uh, don't allow var, using var, always use let or const, and even in that prefer const over let, unless you are reassigning the variables. Then arrow function bodies, curly braces, and finally adding prettier formatting. And the way to actually format this is to go into format document with and see what is the default. You might have to restart your uh, project. So you could do like developer reload window. Okay. And once that is done, then you can search for ESLint and show output channel. The output channel should be the current folder that you are working on. Okay. And there is an error. It says that it failed to load it from this current folder because I have not set the type module in package.json. So let me do that. I'm going to go over to package.json, and right above the main.js, I'm going to say type module, close this, reload the window again, Command Shift P to, or Control Shift P if you're on Windows, Command Shift P if you're on Mac, show output channel, and it should say ESLint library loaded from this. Okay, from our current folder inside node modules from this path. But current folder is important. So if it has successfully loaded, you can go for format document with and choose ESLint and do that. You can also configure your default formatter, which for me is ESLint, because that does the job of linting and prettifying. If you face any issues, you can do, you can open user settings, not the JSON. Open settings UI, search for ESLint, and check this box, which is ESLint format enable. Enable ESLint as a formatter. You have to say yes to that. And that should help you use ESLint for formatting files. And I think that should be it. Any other files that I need to actually add or start with? Uh, I don't think so. I think this is good enough. So let me push this code quickly for everyone to clone it or copy paste it. But I need to take this away for a while because I need to set up my Git. I have like 2 Git installed on this system. So it always conflicts with each other. So I have to kind of fix that sometimes. Okay, I think this should be good enough. Let me bring it back. Okay. Also, I want to change this color theme to be okay. I think this should be good. Okay. Just so that you can see the difference actually. So node module, so what I did, I first did a git init. Okay, this is to initialize a empty git repository in this project. For me it says reinitialized. If you're doing it for the first time, it would be initialized a git repository. Then I do git add and dot, which means add all the files that you see. but it will add everything except for stuff that is ignored. So .env is ignored, so that is why it's more gray. Everything else has this a in front of it, which is like added. Okay, but node modules and .env don't have that because they are ignored from adding and pushing to GitHub. The next one would be git commit, and in our case I would say it is feature initial setup. Okay, and that's done, but we also need to push this. So let me quickly create a project on GitHub. Well, this is weird. Okay, so I'm creating a new repository on GitHub, which is going to be mini-SQL DB. It's going to be public and nothing else. Going to go for create repository. uh, we have already done git init, we have git added everything. uh, we have also done the git commit. So actually, this is what I want to go for, which is step one, git remote add origin. I'm going to copy paste that. Then git branch dash m main. So instead of using a master, the new name is main. Going for that, and git push dash u origin main. And that should get everything right here. Perfect. So I'm going to share this in the chat. I'm going to wait for, like, let's say 10-15 seconds for folks to set it up. The repository is in the chat for you all to see. Uh, so you can copy anything that you have not created yet. Specifically, like, let's say ESLint config, because that was something that I just showed and you still have to add that. So yeah, just copy paste everything, or you can do a one better. You can clone this, right? So you can click on this and clone it via HTTPS or SSH, whatever you have set it up, or you can download it as a zip file and work on it locally. Or the other option is you can fork this repository. Okay, so many things that you could do. Just basically get everything that I have, and I'm going to wait for, like, let's say 10 seconds for everyone to reach on the same page. Once done, give me a shout out. Otherwise, I'll just assume in 1 minute that you're done. Meanwhile, if you have any questions about the setup, please do feel free to ask me. After cloning the repo, should we do anything? Yes, do one thing, which is npm install. Okay, just run npm install. That's it. After cloning the repo, please do npm install. That is a very good shout out right there. So after you clone the repo, after clone, please run npm install on whatever command line. Okay, so you can see I'm inside the repo, inside the folder. You can think of it as after I've cloned it or I've downloaded it on my system, and then on my terminal you have to run npm install, which should basically tell you that everything has been installed, and it should create the node modules folder. Uh, also uh, also create a .env file. As you can see, it has not been pushed. Okay, so you have to create one. So also create .env file. Okay, so there you go. After clone, you have to do two things. What one is create a .env file, which I can add in the README. Clone the project, run npm install inside the project, uh, create a .env file at root. So at root means at like the base, wherever is the index.js, let's say. Okay, that's our root. So we have to set that up. Uh, okay, perfect. So clone the project, run npm install, create a .env file. And now I think I'm going to assume that you all have done all of that. And that's it, actually. Nothing else that you need to do. When I push the second thing, this should go as a part of that. Okay. Uh, Now we actually start coding. Now, before we start coding, the first thing that I would want is to have logging. Okay, a logger. So I'm going to create a folder called as logger. Uh, and we have not specified that right here. So let me add that into my README. Uh, so there's a logger folder, and inside this logger folder, I'll have a single file, and that would be called as logger.js. Okay, yes. So inside this folder, we create a single file as logger.js. Why are we creating this? Because we will, like this whole project would be more of a console application. You will see the output in the console. So we want to do some pretty printing on the console so that it's easy for us to understand what's going on. So that is why I'm going to create these files. And now that we have started coding, you don't really need to see me. You can focus on the code solely. So let's create this logger. And I would say whatever we create here, you can use it in any project. Okay. Which means that for every time you want to print something to console, you can always pretty print it. Uh, so you can copy paste this whole file later in any other project. So I'm creating this inside here. I'm going to give it a description. So this would be @module logger. And next line @description logs messages to the console. So when in future someone looks at this file, they can understand what's going on by looking at what is written here. Okay. And you can see ESLint has started working. It says that delete this enter that you're doing unless you are going to write something. So I am actually going to write import PC from Pico Colors, which I have not installed yet. So let's install this library. Okay. You can find more description about this library on npm. Uh, the description is that it's a tiniest and fastest library for terminal output formatting. Okay, basically adds colors to your terminal. Uh, Colors not to your terminal, but whatever you print on the terminal. Okay, you can make it more colorful. So that's what we are going to do. So like they had some examples. I think. Anyways, once we start using it, you will understand. But this is a library that we need to install, and to install it, we have to do npm I pico colors. So I'm going to do right that. I'm going to copy this. I'm going to come over to my terminal and I'm going to paste that. I'm also going to send it over in the chat. Okay, please run this. And now once done, that should be installed in your package JSON as a dependency. Okay, not as a dev dependency, as a dependency, and this exact version. So this is in. Now this import should work. So if I remove this pico colors, it should now come as a suggestion, as a hint that, oh, you want to add this. So that's our import. Then uh, what we want to do is log the log levels enumeration. So this is basically saying what are going to be our log levels. So our log levels are going to be something like debug, which should actually print out in a square bracket debug. So there's a debug, there is error, there is info. Okay, so I'm making a key value pair that for this particular key, what is the value going to be? So info, and there is success. Okay, and you can always do format document to format it. Like I kept formatting it because for me the shortcut is option shift F. You can see whatever is the shortcut for whatever OS you're using. So we're going to use this. Currently it says assign the value never read, ESLint working. We know that for sure. uh, okay, now we'll create our first function right here, which is to format date, which will take in the input of a date. Now what is this supposed to return? So let me actually add that quickly. So the description, the description is format a date object to a string. Okay, this is what it's going to do. It takes in the the parameter that it takes in is going to be of type date, and the variable is called date. The description is the date object to format. Okay, that's what it's going to take in. And what it returns at the rate returns, it actually returns a string, which is the formatted date string. And we can also add an example. So example, uh, this is supposed to return, or how you will use it. Okay, let's do that. uh, you will actually, I'm going to say format date, which is the name of the function, which takes in a date, which I can say is a new date. It should returns, or it returns uh, I think it would return, we want it to return actually something like dd, or actually not even that. I want to return dd uh, dash mmm dash yyyy, and then space hours, minutes, seconds, milliseconds. So now if I hover over this format date, it actually gives you whatever we wrote. Okay, uh, it gives you a proper description to it. We don't need this dash right here, so I can remove that. So format date, the param is date, not data, it is date. Sorry, right there, date, the date object to format. And you can see that it also gives you this kind of adds this type there, that date is going to be of type date, the formatted date string, and example is whatever we wrote, that use it in this format and it returns something in this format. uh, okay, now let's write this function. So we are actually going to use the built-in library, which we don't have to import, which is called as intl. dot date time format. I'm going to keep the locale as ngb, which is something that kind of everyone uses, uh, and it takes in year, and we say that the year should be numeric. So actually, let me give, instead of this example, let me add today's date, uh, which would be 7th of December. So 07 dash DEC dash 2024. Okay. And space hours, minutes, and seconds, which would be 11:31. Let's say seconds is 15 and milliseconds is 612 or 512. No, 112. Yeah. Okay. So this is the format it should return in. Okay. So year numeric, the month should be, it could be either 2-digit, long, narrow, numeric, or short. We want to go with short, which is like DEC instead of the whole December. The day would be, we wanted 2-digit, then the hour would be again 2-digit. Okay. So HH. So if it is like 1 p.m., it should return like 13. Okay. The minute would be again 2-digit. The second would be again 2-digit. And the milliseconds is actually called as fractional second digits, which would be like we want up to like 3 places. And the R12 is false, like 12-hour format. No, we want it in 24-hour format. And then here, right here, before this semicolon, I will call the format on the date. Okay. What is this date? This comes from what the input that was here. Okay. That gets passed here. So so the way to read this code is that format, like using these settings, format the input date which is returned to you. Okay. Now what else? Actually, I can write this very quickly. Export function logger. It takes in a level, it takes in a color function, it takes in a log method, it takes in the message to log, and dot 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 args. Okay. uh, so let's add some description to this. First is, what is this thing about? So logs a message to the console. Okay, this is the main important entry point function. Let's say the first parameter is going to be of type string. It's called as level. So this is the log level. Okay, log level, you remember our log levels, we have debug, error, info, success. Okay, so those are our log levels. uh, the color fn, now this is going to be interesting. uh, You're actually not going to take it as, yeah, actually going to, yeah, we are going to take it as input, which would be pico colors color. Okay, the log method, it is actually going to be console method. So you have different console methods. Example, if you do a console dot, then you have these many. The ones that are normally used is console.log, but you have console.info, which prints the same thing. You have console.table, console.time, you have console.trace, you have console.warn. Okay, these are different log levels that you can have. uh, so that is the console method. The message would be message to log. here I can say console.debug, console.warn, etc. Okay. uh okay, what about the types? So color function would be more of I would say should be more of a function. Okay. Log method would be again a function. It would be of type function. The message would be actually of type string. Okay. And the args is going to be any array, and you can say that this is the additional arguments to log. Okay. Okay, perfect. And we'll add an example soon. uh, so just bear with me for the time being. Const timestamp equals uh, what the format is going to be. So inside a square bracket, curly brackets, and we'll call our format date function, which will take in a new date. Okay, so that is our timestamp, the current timestamp. We'll create another const colored level, which will be the color function that will be passed to the level. And the log method would actually be something like dollar curly brackets pc dot dim the timestamp. Okay, so this is more like not exactly seen. Then dollar colored level, and then whatever is the message, and then we can do comma dot args. Okay, anything else is printed, and we will soon, very soon, see this in action. Okay. So the first one is that I want to show you is error, so you can see the coloring exactly. So I'm going to create a new function called as export function log error. It takes in a message comma dot args, and what it returns is it calls this logger that we created right here. So calls this logger, and then it passes in some things. So from the log levels it passes in the error. So this is the log level. As you can see, it gives me a hint that the first one is log level. Then the color function, I say it needs to be yellow in color. No, if it's error, that it needs to be red in color. uh, the console method is going to be console.error. Okay. The message is whatever is passed by the user, and the args is whatever is again passed by the user. Export function log error takes in these things. Now let's use it so that it makes it more easy for you to understand. So I'm going to say uh, what can I do? Let's say I will say logger, which gets imported from dot slash logger slash logger.js file. Logger, uh, or not even logger, we want to call the log error. Okay, so not the logger, we want to call the log error. And log error, we can say this is my error. Okay, this is what I'm doing. I'm calling the log error and saying this is my error. Let me clear the console and let's run this node space index.js file. And once I run this, do you see this? This is what I'm talking about. Okay. Also, I think I made a mistake in the format. Let me copy paste this format right here. Without the brackets, because brackets is something that we are adding later. Okay. So do you get an idea? So it prints this error in red. This is the timestamp which is kind of dimmed, and this is the message. But what if I want to log more things. So I go like, this is another error. Okay, let me run this file again, and it prints that out as well. Not in different colors, but when you have so many of things, then you can kind of see that this gives you a definition of, okay, this is the error. Okay, and it's in different color. So I hope the logger function now makes sense. The logger was taking into consideration the log level, which is the error, and the color function was kind of wrapping this pc.red around the level. So if it was yellow, which let me try and make it yellow, and I run this again, it's in yellow. There's also other colors. So I'm saying that take in the level, which was this. So take in this particular string of error and make it whatever color the user has defined. I don't see much difference here. Okay. And the log method is console.error. I can also make it console.log, let's say, and doesn't make a difference as such. Okay. But it's good practice to kind of show it that, oh, this was an error, the message and the args. Hopefully that gives you an idea. And let me also add some description to this very quickly. Uh, uh, Message would be string message error message to log, and this would be an anything which would be additional arguments to log. So now if I go over to index.js and I hover over it, it gives me the exact description of this. Okay. So similarly, we have to create for debug, we have to create for info, we have to create for success. Okay. And well, since I've prepared for this session, I can quickly copy paste that. Okay. So log levels, log debug, there you go. Then what else? The log info, and finally the log success. So you can see that they are nearly the same except for the colors. Okay, the level, the colors, and the log method. Everything else is just taking into account what it needs to print. Okay, log success, of course, it's going to print in green. The log level is success, square brackets. Info is going for console.info. The debug is going for console.debug. Error is going for console.error. And that's it, actually. And anytime we want, oh, success is going for console.log. Okay, I don't think there is a console.success. Yep, there isn't. So that is why we are going for simple console.log. And to see them in action, I can kind of add them here. I can do log info. My info. Then you have log success. My success. What else is the log debug? Okay, and let me run this file. And there you go. Different timestamps, and tells you exactly like when was it printed, whatever time. You can see there's quite some difference between the error and info. I wonder if this is because of the second argument, because that's big. Let me try it again. For some reason it's still there. uh, and different colors. Okay, you see the different colors. That was the main point of this. And mostly it should work on any console as far as I know, because that's what Pico Colors is supposed to do. It should make it work in any console which has kind of your color terminals enabled. Okay, and let me push this without any of this. Okay, you don't have to do this. Or let me push it with this for now. So feature added logger. A simple git push, and there you go. Logger has now been added. And let me copy paste this in the chat. There you go. And hey, hi. Long time no see. We saw each other in last GHW session. Uh, okay, so that's our logger done. And let's move on to the next one. So we have added our logger. What next do we want to add? So we added the logger specifically because when we start writing code, we'll encounter some errors, some success, or something. We want to pretty print it so that it's easy to debug. So that is why we added our logger so early on. Next, we want to create a new folder called as lib. If you remember it from the readme.md, so lib. And the first thing that we are going to create inside that lib is going to be storage. Okay. So the first file is going to be storage.js. Now in the README, I'm going to actually specify that storage.js, because storage.js, that is going to be the core library folder for creating files. Okay. No, actually, I would say this is more like not folder. Wait, this would be core library file. Why did I write folder? For creating JSON files to store data. Actually, let me even improve this. Creating JSON files to store data and run read write operations. Okay, I think this is a better description. So storage.js, what are we going to do? We are going to create like write some functions to actually create JSON files. Now these JSON, like create a folder, then create JSON files to to store data. So you remember our create table syntax. Now this create table syntax, what this will do in our code base is it will create a JSON file, which is a key value storage, which is more of a NoSQL thing, but the operation will still be SQL in like the syntax that we use would be SQL syntax to create a table which will get converted to a JSON file, which will create the columns would go as keys, the rows will go as values, and yeah, that's it. Okay, so once we start writing the code, that gives you more idea, but for now just understand that the storage.js is what we will use, or what the users of this library will use to create a database. Okay, also for the future, 3, 4, 5, 6, I think as far as I remember, we should have only 6 things, okay, in our project, 6 files. which we will create one by one. I'm just going to copy paste that very quickly. Okay. So storage.js. Let's start writing what should be in storage.js. Okay. So for consistency, I'm going to say that this is inside the lib folder inside in the file called as storage.js. It is going to be like @module. This is the storage module, and @description handles file based storage operations. Okay. 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 So some things that are kind of inbuilt uh, already in the Node.js, which would be file system. So import fs from fs. So this is the Node fs module that enables interacting with the file system. Okay. Next is the path. So import path from path. This is for the node path module. It provides utilities for working with files and directory paths. Okay. And do you see this module path? Okay. That when we create this as a library, this @module, which kind of, you know, create what we are doing. So what next? There are a few other things that we can kind of import, which are inbuilt. Like these are the libraries that we did not do a npm install or add to our dependencies or dev dependencies. Okay. Now this has a bunch of things, but from this, uh, what I want is the file URL to path. Okay. What is it for? It is to ensure correct decodings of percent encoded characters, as well as ensuring cross platform valid absolute path string. Because uh, yeah, there's this Windows versus anything else. Hmm. So if you like use this kind of path, then in case of Windows that becomes incorrect. But if you use file URL to path, it actually understands that it needs to convert to backslashes in Windows. Okay. So yeah, that's why we are going to use, so that our project is uh, works across. Okay. The first thing that we are going to do is const underscore underscore file name is going to be file URL to path, and that would be import dot meta dot URL. Okay. So the file name, whatever is the file name that the user inputs, we convert it to ensure that the correct path is there. Then you have the const underscore underscore dir name, which would convert the path inside the directory. So you don't have to exactly understand this one, because once we start adding stuff, it's more easy to understand. So what we want to do is, when someone uses this project, we want them to specify the path to the folder, to the database folder in the .env file that we have created. Okay. So they can actually create something called as the mini underscore SQL underscore DB underscore path. Okay. Which is equal to something like, let's say, in the current directory, create a database folder. Okay. Yeah. So we want to read from this env file. Then based on where the user is running this command from, if they are running it from like this mini-SQL db, okay, from the root, then take that path as the root of the project, and on this path create a database folder. Okay, that's what this means. So now if I run this command from inside the logger, okay, then it should read this path, the current path that the user is on, and then create the database folder inside the logger directory. Okay, so that is what this is kind of doing. Like, first is taking the path properly to understand, okay, and then path dot dir name is to return the directory name of the path. This is more like to convert between Mac OS and Windows. Okay. Yeah. Sorry. Uh, okay. What next? Okay. We need to install a library now. So we need to install a library called as .env. Okay. And if I go over to my package JSON, yes, there we go. So I have to run this because this is a library slash a utility that allows to read from the from this .env files. Okay, you can find more information about this on right here. So the command that you need to run and more information on this. Okay, so once you have installed it, let's import it. So I'm going to say import dot env from dot env. Okay, and what next? We want to tell it to explicitly load the env file from the root directory. So I'm going to say the path is actually going to be path dot resolve uh, the directory name. Hmm. Okay, so this should be like if you are inside a particular folder, then this should resolve it or go back from there. Okay, or actually, do we need this? Let me think. Let's say I don't use. I'm confused. I think when we actually start experimenting, that's when we'll know for sure. Or I can actually, let's do this. Let's console log this. Uh, underscore file name and underscore dir name. Okay, just going to console log these two things. But one thing that we definitely need is the database path. So export const database path, that is going to be process.env process.env dot mini SQL database path. So whatever we actually added in this inside the mini SQL inside the .env, so we are saying that read from this particular thing. So go to the .env file and search for this particular key. If it is found, then use that to be the database path, or in the current directory wherever you are. If that fails, okay, if the previous one fails, uh, create a dot slash database folder. Okay, so create a folder. So this means that in the current directory, create a database folder. And actually, this is not even creating it. We have to write something to actually create it. So this is more like to say that this is going to be the path. Now let's create it. So we will say that if not fs dot exists sync. Okay, so exist sync is basically to synchronously create uh, a folder, a directory, and what is the path to it is what is required. The path would be the database path. So create a folder if it does not exist already. fs.mkdir sync. Okay, we're going to go for synchronous one. There's also a async one, and then we will say recursive is true if there are any files that we need to create inside it. And we can always do a log info here. We have a log info, right? Okay, so log info, we are going to say that database directory created at whatever path. Okay, and this we need to import from logger.js. So if you are importing something from a library, from a file in your own library, you kind of, let's say, I found that you have to add the extension there. But if it's a library that's imported from node modules, you don't have to add the extension, of course. Uh, hmm, what else? Okay, let's test this out quickly. So how are we going to test it? Oh, very simply. Let me go back one step. Okay, now I'm going to say node space, inside the lib folder, go inside the storage folder file, and hit enter. So if I do that, it actually created the database in the root slash database, and you can see this is the folder. Okay, a database folder has been created, info. Now let me actually go inside the lib folder. Okay, so now I'm inside the lib folder. Let me delete this one. And now if I run node space storage.js, okay, because in the current folder I have this node storage.js file, I hit enter, it created a database in the current directory. Okay, it created a database right here. Now what I could do is, if I do this and if I do this, okay, that still wouldn't work actually. Okay, and you can see the current file name. Okay, this is what is the file name, and this is the directory name, the dir name. Okay, that's what's being created kind of. uh, I wonder one thing though. What if I actually don't do this? So if I go over to .env and I read the documentation, I can do import .env/config and just do .env.config. Okay, let me try this. I think maybe that's what I was missing. .env config, and that's it actually. Don't need all of this. Okay, so code correction. Uh, do I need this? Nope, actually. Interesting. I can get rid of most of this code because it works actually without it. I wonder why I had added it. Probably because it wasn't working at some point, but now it is. So I'm going to remove it. Okay, cool. Anyways, I think that's good enough. So we have successfully created a file, or a folder actually in this case, of database, and with minimal code. We are adding this just so that this works out well. If I don't do that, let me see if it still works. It does, interestingly. But I think it's a good idea to always add this .env config so that if you have to kind of change it, you can. This is specifically for reading from the .env files. Okay. I can also create a .env.example so that folks know which key to specify. Okay, and .env.example is what is generally going to be pushed out. Okay, so you might have seen in so many other repositories that you specify the key but you don't specify the value. For example, if you're creating something for Mongo, uh, which uses a MongoDB URL, you will create an example with MongoDB URL equals to and keep it empty. And then in your README, you would say that please enter the MongoDB URL in the .env file. So you can copy paste the keys from the example, create your own .env file, and add the values. Okay, so that is what the example is for. Uh, and I think this is a very good time to take a 10 minutes break. Let me come back on screen. Too big, too big. Okay, perfect. Okay, I think this is a very good time to take a 10 minutes break. What have we done till now? We have successfully created the database folder. That's it. We still have to create a table, insert into the table, and run the select command, which we will do in the second session. So the second session has kind of already started. We'll take a 10-minute break. We'll come back. Then I'll give you the link to register for the second session, and then we'll take it from there. Okay. Meanwhile, I will push this. Okay. So I think that should be there. So now you should have the latest code that I had. Okay. And yeah, that should be good enough. You can run it by doing what I was doing, which was node space. Where is the file exactly located? It's inside the lib folder in the storage.js. You hit enter, and that should create the database folder. And this will not get pushed because it's in a git ignore. Okay. Just remember that. I'm going to delete it for the timing. Okay. Cheers. We'll be back in 10 minutes. Take a quick break, eat something, have some water, and then we'll be back to continue with the session. Hello, hello, hello. I'm back. Okay, good music, I think. Uh, okay, hello and welcome back. Hopefully, you had a quick lunch. I had a quick lunch or breakfast, dinner, depending on where you are, and just stretched around a bit and stuff. So that now we are ready for another 2 hour session of this mini SQL DB, where we have currently only reached till creating a database folder without any files in it. Uh, but we'll reach there. We will reach there. Don't worry about it. Okay. Uh, okay. Let's continue coding. So what's the next step? The next step is to create something, right? Okay. Uh, can I give it a description? Let me add this. Create the database directory if it doesn't exist. Okay. And what is this line doing? Path to the database file. Okay, let's create the first function which is going to be used, which is going to be called as get table file path. Okay, so we have created a database folder, but internally we want to create a table which is going to be more of a file inside it. Okay, so we have created the folder. Inside that we want to create the file. So we will say gets the file path for a table's schema, schema, or data file. Okay, what is it going to do? It is going to take the first param, which is going to be of type string. Okay, and that the variable would be called as table name, which, as it suggests, the name of the table. Then the next thing that it is going to take is another param, which is going to be string, which is going to be file type. Okay, and the type of file. So we'll have two types of files. One is called as schema, or the other would be called as data. Okay, difference we'll see in it in action later. So, and it, what does it returns? It returns the file path. That's all it does. Something very simple. Returns the file path. So let me do a export function, export, so that it can be used in another file, uh, and we'll call it get table file path. Takes in two parameters. You know what all it is: table name and the file type. And we will say that the default file type, if not specified, is going to be data. Okay, always. And what we will do is return path. You remember path? We have to import it again now because I removed it. But return the path dot join whatever is the database path, wherever was the folder created. In that particular path, I'm going to use backticks because I want to add variables inside it. Table name dot dollar file type dot json. Okay, this is what is it is going to return. So if you have to think about it, think that there is the path to database folder, which is, let's say, in the current directory. In the root of it, you create the database folder, and then you say the table name, which let's say called users. Okay, users dot data dot json, or if the file type is schema, then users dot schema dot json. And what will the schema contain? Now, does it make more sense? The data contains the actual data of, like, whatever you're adding. Like in our SQL syntax.txt, the actual data was 1 Alice 30. or 2 John 45. But the schema was integer, text, integer. Okay, something like that. I hope that makes sense. Yeah. Okay. Also, I can go away so we can focus solely on the screen. Okay. So our get table file path actually returns that we want to actually next create the JSON, read JSON. What would it do? It reads a JSON file and returns its contents. Okay. It would take in first the string and the file path. Okay. It needs to take the path to the JSON file, and it returns either an object or null. Okay, it can return an object or null depending on whether it found the data or not. Okay, so it returns the parsed JSON content or null if the file doesn't exist. Okay, let's create this function. So we will call it very simply read JSON. So export function read JSON. It takes in the file path. There's no default here, of course. Now const parsed data will be fs, which we need to import. I think we have imported it already, right? Yep, import fs from fs is done. Dot exist synchronously. So let's check if it exists, file path. Okay, so we are saying that check if this file path exists. If it exists, then since the data that we are storing it is in the JSON format, we will say json.parse fs.read file sync file path. Okay, so read the file, get out the data, and since it is going to be in JSON string, parse it. Okay, using json.parse, and else return the null. So this is to check if if it exists, then parse the data, else return null. And now we can do some error logging saying that if not parsed data, which is this variable right here, if this does not exist, then in that case we will do our very simply log error, and we will say that inside backticks, I'm going to say, because I'm going to also add the dollar something dollar variable. Okay, so dollar curly brackets, which variable? File path. So we will say that, oh, we did not find the file that you suggested we will on this particular file path. And once that is done, we will just say return parsed data. So now parsed data would be kind of either null or it would be the actual object. Okay, a JavaScript object. Yeah. Now we have read JSON. We also want to have a write JSON. Okay, so we'll say what would this function do? Write JSON. It would writes data to a JSON file. It would first take in the param, which would be, now you can kind of repeat after me. If this was a class, I would ask the class to repeat after me. It would need a file path, right? Path to the JSON file and param object data, which would be data to write. Okay, what would it return? So after the data has been written in the file, Why would you want it to return anything, frankly? Okay, so we can kind of ignore, or if if it successfully found the file path and stuff, then uh, yeah, we could do some checks like that, but I'm going to keep it simple for now. Export function write JSON to whatever is the file path, command data, fs.write file sync, take the file path, and then save it as json.stringify the data. And the first is the value, then is a replacer. Now we don't have any replacer, we don't want to replace anything, so null. And then is how many space or indentation that you want to add. I want to add 2 spaces between the data so that it's easily readable. So what I mean is, if you have data something like this, and you see this space 1 2, this should be automatically added. Okay, okay, I think this should be good enough actually for now. So that's our storage.js completed. Okay, we have reading from, like, actually creating a folder, we have getting the table file path, reading JSON, writing JSON, and I'm going to add a homework here. So I'm going to add to do. Okay, homework, write validation for file path and return error if not found. Okay, so I've written it as homework, so you can think of it as when you're building this and when you want to come back to actually learn something, you can kind of try to solve this, which should be very easy to solve. Okay, because we already have get table file path, so should be easy. uh, okay, that's storage.js done. What's the next one? Well, we need to add the create table query and the insert into table query. Okay, and should have given you an idea that the next file that we are going to work with is query.js, right? Parses and executes SQL queries. Now this is where it might start becoming a bit overwhelming, but just stay with me, please. So we are not going to import anything for now. I'm just going to start with writing a function and then we'll start doing stuff. So what's the first one? We should start with create table. Actually, so I'm okay, so we don't want to do query first. So I can ignore this. We want to do a schema first. So schema.js. Okay, why we are doing schema first? Because the create table is actually going to be what schema to use to create something. Okay, so that is why I'm going to create a schema first. So I'm going to say lib slash schema.js. This would be module schema, and at description would be handles, table, schema, management, and validation. Okay, good description, I guess. uh, so what's the first one, or actually kind of the only one that we are going to do right now, which is going to be create table. Okay, so the description would be creates a new table schema and initializes the data file. And at the rate parameter, there's one parameter that it takes, which is going to be string query. Okay, and it takes in the SQL query to create a table. Export function create table. It takes in a query, and query is going to be of type string that we have to find. Now this is going to be interesting, and this is the pattern that we are going to follow everywhere. Okay, so please give your 100% attention right now. So the first thing is that we will create a matcher, and we will say that query, which is a string, there is a match method that exists. Okay, so matches a string with a regular expression and returns an array containing the results of that search. Okay, so what is our regular expression going to be? So our regular expression, as you can understand from the SQL syntax, which I will open on the side, the create table takes in this. Okay, create table, it needs to have that syntax. So I'm going to say / create table. Okay, after this I'm going to say, like, this is how you read a regular expression. Okay, so create table takes in, like, it has to have this word, create space table, and then we are going to say that it takes in any word. Okay, so any word plus, it's in the bracket saying that it takes in any word. After that we will say that it takes in hmm, anything with, like, inside brackets. Okay, uh, anything inside brackets. So create table, then a word, one single word, which would be users, let's say, and then inside brackets it can have multiple things. And then to terminate this, wait, let me count the brackets. /I think that should terminate it. Okay, perfect. So now we can, let me console log this. Console.log match. Okay, I'm doing a console log, and let's do, like, add some create table query. So first is going to be a string, which would be my table users, uh, id integer. Okay, let me clear this. We are in the root folder, so I can do node space lib slash schema.js. And if I do that, it returns null because it did not work with, like, it did not have this create table. What about if I do create table users and id integer? If I run that, it returns null. Okay, what am I missing here? uh, what about the space in between? And there we go. So create table something, space in between, and then you have things inside. If I do just id, okay, that works out as well, uh, kind of, which is bad. But for the time being, for our initial phase, or let's say MVP, we don't care about it. We'll assume that people will actually put in the schema properly. Okay, we'll actually add checks to it. Yeah, let's do that. We will add checks to this. So this actually returns one, two, three, four, five, six things. The first thing is it returns the exact string that was entered. Then it returns this part, which is the W plus, which is users. Then it returns this part, okay, the ID integer. So instead of ID integer, what if I have name text as well? Yeah. So then the second part is actually whatever was entered inside the brackets. Index 0, no idea, frankly. Input is this thing again, okay, and groups undefined. But ideally, I hope this makes more sense now. Okay, what are we doing with our query.match? We are saying that match anything if it is, if it matches the create table space whatever is the name of the table, so one word. So if I do users me and I run this, that returns a null because it does not match this regex pattern. There needs to be one word only. Okay. And then what if I remove the brackets? Let me see that as well. Null, because it needs to have a bracket, and inside that bracket you can have multiple things. If I do a ID comma integer comma name comma text, I think that should work because we have not specified anything for that. Okay, but we can also uh, mm, add regex pattern to match that. But for now, I think this is a good enough start. Okay, successfully getting the input, the table name. So we can call this as the table name. This is the fields in the table. And if we break it on space, then we will also get the schema, right? So that's a good thing. Let's add a few things. So first step, what if no match is found? So if no match or not match, in that case, log error, and we will say invalid create table query. Okay, if there is no match, and then we'll also do a throw new error and copy the same thing. Okay, why am I doing this? Because when we use it as a library, it would be shown to the user as an error. It would be an unhandled error. Now, remembering this output, okay, keep this output in mind, and I'll close this and zoom in a bit. So keeping this output in mind, let's add our next steps. So next we want the table name. So const table name, that is, now match is an array. Okay, so this is the 0th index, this is the first index. So match of 1 is the table name. Now we can add some validations. Let's say the first validation is if table name dot to lowercase. Okay, so we'll lowercase whatever is the table name that the user has given, if that is triple equal to tables. Okay, if that is triple equals to tables, then that's a bad idea. Okay, that should not happen. So log error cannot create a table named tables. And then we'll do our very famous throw new error. Okay, what's the next one? The next one would be if someone tries to create a table name called as columns. That's a bad idea as well. Okay, that is, I think it also gives error in one or two databases. So if someone tries to create a two lowercase bracket close equals columns, okay, if it matches exactly columns, then again log error cannot create a table named columns. And let's throw new error. uh, ah, Bad idea. Copy this thing, paste it right here. Okay. Next is a variable called as columns. Okay. How do we know which are the columns? Because the second part is what we need to focus on. So const column equals match of 2. So 0, 1, 2. So match of 2. And in this case, we will do a split on it and we will search for the separator comma. Okay. Once we have the separator comma, which is id space integer, comma, namespace text, we'll search for this comma. And once we have that, then we will say dot map or loop over it, call such that we remove any additional spaces around. Okay. And if you see, this is what I had. And now if I do a format document, adds this brackets and spaces and stuff. So columns, we are saying that take in this part, split it on the comma. Once you split it on the comma, there would be this space left around the name text, right? So take that space and remove that space. Okay. Call.trim is to remove any additional spaces around. Now the next step would be to actually take in the schema. Okay. So const schema equals the columns that we have, then we do a reduce on it. Okay. And it's okay if this sounds a bit weird. So what we are saying is it takes in two things. The reduce takes in the accumulator and each column. So this is another way of saying go over or loop over this whole thing and pick out the name and the type. And this should be a call dot split on space. Okay. So we are saying that for each thing that you get back in the columns, actually let me try and print that. Okay. Console.log columns. Before we go deep into it, clear and run this. And this is what you had in columns. You had two things. Also, let me do a console.log match. So this is our match and this is our columns. So columns has two things here, id integer, and it is split on the comma. Okay, so this is the first zeroth index in the array. This is the first index in the array. And now in with reduce, what we are going to do is separate even these two out. So id space integer. Okay, so id would be the name and type would be the integer. Okay, name would be id, type integer, and we will say if not name or not type. So what if someone has added a name but not added a type, or they have, like, I don't think you can have not name and just have a type. That's possibly interesting. Need to think about it. But anyways, if there is no name or no type, in that case we will do a log error saying that invalid column definition. Okay, so if someone adds a name, does not add a type, adds a name, does not add a type, that should log an error. So if I run this, error, invalid column definition. And we will also do a throw new error. And we will copy paste the same error. So when I ran it for the first time, all it did was console log, like kind of print it. But if I do it with throw new error, you can see there is an error here in the whole thing. So now when someone runs it, they can see this error printed, but also get this error, because of which they won't be able to run their project further. Okay, and until they fix the error. So if no name or no type, in that case, error. ID was integer, name was text. Okay. And now we will say that take the accumulator that was there, and for each name, make the type to uppercase. Okay. So if someone goes like ID, integer, name, text, what this is going to do is, for ID, when you have the type, make it uppercase so that it's kind of easy to understand. And then we are going to return the accumulator. And then there is a second parameter that it takes, that it starts with the current value of empty object. Okay, so from an empty object, we go over the columns, and then we split it out. Then we throw an error if something doesn't exist. If it exists, then create a key value pair where the key is the name and the value is the type to uppercase. And let's print this schema. There we go. Okay, ID colon schema, like ID colon integer, name colon text, and so you have a key colon value. Okay, so this is your current value, what you start with, which is going to be create an object. Okay, please create an object and key value pair, because remember we have to kind of write this into the JSON file. So that is why we are doing this whole reduce operation to create a object slash JSON, if you know, if you understand that. Okay, now next is, let's do some schema path. It's going to be get table file path, and it takes in the table name. And you remember there was the type, so there's the schema, and then const data path is going to be get table file path again. This will again take in the table name, and the type would be data. Now if I don't specify the type data, it should take in the default. So but for consistency I will specify it. Write JSON takes in, it took in two things. It takes the file path and the data. So the file path would be the schema path, and the data would be actually the schema that we created, right? So this is the schema, this object that goes to write JSON. And then we'll do another write JSON, and we will say it takes in the data path. Okay, and the data is empty. Okay, why is it empty? Because technically we haven't created any data, we haven't added, like, what was the data? The data was this whole insert into thing, right? So the data 1 Alice 32 John 45 does not actually exist. So what are we doing here is, because we are creating the schema based on whatever is the schema definition, based on the table name. Okay, so table name, like in this case, was users. So when we are creating the JSON file for schema of users, at the same time we'll also create the data file, okay, and use it later. And log success uh, table name created successfully. Okay, I'm using exclamation marks because I'm too excited for this table name to be created. So now let me clear this all out uh, and focus only on the schema, and let's run this. So node space lib/schema. There is no database folder right now. I'm on the root folder and I hit enter, and there is a problem. It says cannot find module blah 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 blah. Okay, what did I do? Storage.js. Okay, so now you know the error, what happens when you don't do this. Clear it, hit enter. Perfect. So success table users created successfully. Let's check it. So database folder, it has the users.data.json. So we did not have the database folder, but it created that as well. There is a users.data.json, which is an empty array, no data inside. And users.schema.json has our like schema, which is this is the key and this is the type. This is the key, this is the type. Okay, the name and the type, the name and the type. And this is based on how did it get created. This is based on whatever we wrote in this create table query. So what else can we write here? Let me see. Name, ID, age would be text. DOB would be text. Student would be boolean. Like, is this person a student? Yes or no? I think this should be good enough. So let me clear this. And if I run this again without deleting anything, if I go into data, that's still empty. And if I go into this, yep, there we go. Okay. Perfect. Now we can remove all our console logs because we don't really need them. What we need at the end of the day is either the success message or any failures that happen would happen in between. Okay. So example, if I miss the table name and run this, an error, an invalid create table query. I add that, I forget this thing, error, invalid create table query, of course. If I add student, remove the boolean, error, invalid column definition. Okay, so it's not going to allow me to do it. But when everything is fine, table users created successfully. Okay, perfect. Any questions so far? Let me come back on screen. Any questions, anyone so far? We have done like what, 3 hours of session, and we have successfully created the database. We have successfully created the run the create table query, and also we don't really need this here. Okay, to test our code, I'm going to actually create a test folder. Yeah, so I'll create a test folder, and inside this I will create a test underscore db.js file. Okay, so all the testing that we are supposed to do, I'll do it here. Okay, why? Because then we don't have to do a console log or run the function then and there itself. So let's create our first function, which is test create table. I'm going to call it underscore v1, and const create table query is going to be create table users id is going to be int, name is going to be text, age is going to be int, uh, student is going to be boolean, uh, hmm, I think this should be good enough actually for now. Okay, and now for any errors or anything, what we will do is we'll call this create, sorry, not create table query, we'll call the create table, which was, it should be imported, right? And try and catch error. Okay, perfect. So create table, why is, there was an export that I wrote, right? So schema export function create table, not so smart in it. Import uh, create, import actually from dot slash lib slash schema dot js, and there we go, create table. So create table, it should take in one thing only, which is the create table query. Okay, the query, so it takes in this, and we will use the logger from js, and we will say that the log level in this case is test, and okay, pico colors will import, like we can, let's say short format pc. So pc dot magenta, the log method is going to be console dot info, and what is the message? We are going to say table creation test passed, and then do a new line. And in the error, we will actually use the log error, and we'll say table creation test failed, and whatever is the error. Or actually, you can do this. Let's forget about log error. We'll call the logger test pc dot read console dot error table creation test failed, comma error. Okay, and now how do we run this? Well, very simply, we need to call this function, right? You can create a main function. So function main, it calls in the test create table v1 function, and to run the main, simply we do this. So once we create more and more functions, if we don't want to run something, we can just comment it out. Okay, clear, and let's run. Now we will run the test slash testdb.js, hit enter, and there we go. So this success comes from the actual schema.js file, and this test comes from this thing, right? And if there was an error, so let's say if I forget this users, clear this out, hit enter. So there we go. error in create table query. This test table creation failed. Okay. And then the actual error because of the throw new error that we had. Okay. Yeah, so every time now we want to test any of the new functions that we create, we will actually do it right here. Okay, we'll create more and more functions here. uh, Also, just to let you know, like the syntax version, you can always do export const main equals, so basically the arrow function. Okay, so this will also run very similarly. Let me fix this. Okay, I'll leave it as this for the purpose of that you can use arrow functions. That's okay. Okay, cool. uh I think this should be good enough. Let me think. Okay, let's go into query. Okay, the first query that we are going to write is the insert into query, which we had actually started, and then we realized that where do we insert the data if we don't have a table? Oh, also just to check that, let me also delete this. So when we start fresh. The first one is insert query. So inserts a row into a table. So focus on the wordings. I'm saying insert a row into a table, which means in a single table, which is of course, which is how the SQL works, you can insert one row at a time. So we can say that later on, one of the modifications that we will make is to insert multiple rows of data. It takes in the param, which is the query, and it would be SQL query to insert data. Okay. Now that we are writing some code again, you can focus solely on the code. Enjoy. Okay, we can do export function insert into the query, whatever is going to be passed. Uh, yeah, SQL query to insert. Okay, and let's follow the pattern. The first thing is we do a const match, which is going to be query dot match, and the insert into syntax. Let's quickly add that here and make this small. So the insert into syntax actually starts with the word insert into. Insert into, and then uh, it takes in the table name. So we'll do what we did before. So we will say that take in a single word here. Okay, W plus, and then uh, now this is going to be interesting. Insert into, then it takes in the column names or the fields. Okay, so we will say that in this now backslash brackets another one dot plus, saying take in multiple things right here, and then it needs this keyword called as values. Okay, so values, and then it would be this thing again. Okay, take in multiple things and /I. So this is our insert into query. Okay. Yeah, query dot match insert into and w plus and values and stuff. Okay, perfect. So now if there's no match, if there isn't some error, we'll always do logger dot error. Okay, log error, sorry, not logger dot error, log error, and it takes in one single message, which would be invalid insert into query. You can make this more smart by, like, let's say someone, give me 1 second, sorry. Okay, sorry, I'm back. uh okay, so you can make it more smart. As I was saying, you can make it more smart by actually ensuring that uh, this insert into query checks in if the word values is missing, if the word insert into is missing, and then return the error accordingly, return the error, appropriate error. Okay, so you could do that. I'm not doing it, but let's consider it as another homework. Okay, throw new error, invalid insert into query. Perfect. So it needs to match that regex slash regex pattern. And once it matches, that's good. If it doesn't, then this is what we are throwing. I would say to do homework could be make it smart by checking what is missing in the query. Also, currently it is all caps, right? So another thing to focus on could be if I can make it like, small case. So once you receive the string, uh, break the string, uh, make everything small case, or see if you could use some regex to actually uh, check, like, instead of capital or small, both of them work. Okay, capital or small work. So I'm going to actually add that as well. Make it case insensitive. Yeah, this is what I was thinking about. Okay, now once done, then we kind of remember from our previous interaction that the first place is the table name. The const columns would be on the second place. So we can do not math, match of 2 dot split on the comma, and then map over it. And for each column, ensure that you remove any additional spaces that might arise. I'm going to close this one. So trimming all the spaces around the columns. The const values, okay, anything that comes after the values, it would come on the place of match 3, okay, dot split on it. It will have a comma as well, and dot map, and we'll say this is value, and then we'll say val dot trim. Okay, so removing all the spaces around the values. And we can also me think. Actually, let's uh, print this on the console. So console dot log the match, console log table name, console log columns, and console log values. I think these are four things that we want to print. We can go into our test DB and we can start creating test uh, create insert into, let's call it insert into, not create, oh, test insert into underscore v1. Now inside this function we will do a const insert into query, or insert query. We'll do two of them later. So let's start with the first one and we will say insert into users. What columns did we have? We had the ID, oh, name, age, student. So insert into users the column names, and the values would be ID1, name, let's say single quotes Alice, age 22, student true. Okay, and now that we have the query, let's do a try catch. Inside the try, we will call the insert into, and I'm very picky about this, so logger goes up and this comes down. Okay, so insert into, it takes in the insert query one, and that should be good enough. And we can copy this, test magenta, and insert into test pass. Okay, and for error we can just copy paste this. And the only difference would be this would be a console error and insert test failed. Okay, also okay, let me add the error as well, and let's run this. So node space test db.js. Oh, we haven't called it. No wonder it wouldn't work. Okay, there we go. This is from the previous test, so you can ignore that, but this is what we need to focus on. Insert into, this is the output. Okay, so this is the initial query, this is the table name, this is the columns, these are the values. Okay, and this is what is happening. We get everything individually. Now you notice this around Alice, there is this string. So what if you did not add that? It still works. Okay, there's no problem. But when someone will actually add this thing, when someone would actually what do you call, add this query, they would use like single inverted or double inverted commas around it to kind of denote that it was a string slash text. Okay, so we can handle it in a way, uh, in our code we can handle for the single strings by doing something very simple, which is by replacing stuff. Okay, so I can say like dot replace and we'll say replace the single inverted comma for global, like replace all of them with a double inverted. Okay, so you have to remember this one, focus on this one. When we had added a single inverted comma, so there was a double inverted and a single inverted. Now let me clear this and run this again, and there you go. Sorry, replace not with double inverted, this is replaced with nothing. Okay, so remove all the single inverted commas that exist, extra single inverted commas, and replace them with nothing. uh, what if someone did the exact opposite? So if there is a single inverted comma on the outside and there is a double inverted comma on the inside, okay, this is a valid JavaScript syntax. And if I run this, this is what we end up with. Okay, single with double. So yeah, that is kind of a dilemma that we might need to fix slash focus. We can go like, again, replace. What is the string that we want to replace? Double inverted slash g, and replace them with nothing. So now if I run it, that works. Okay, so if a single inverted comma, replace them with, if there is an extra inverted commas is what we are focusing on. Okay, if there are extra inverted commas, what you need to do is replace them. Perfect. Now we have also started using testdb for our, for checking stuff, for testing whatever we are doing. Okay, next, schema. So we can read the schema by calling this read JSON, and then calling the get table file path and giving it the table name and the schema type. Okay. The get table file path, it takes in the file type and the table name. So we are saying that tell me what exists on the particular table name. The table name we are getting from because of the insert into table is specified, right? So that's how we get the table name, and that's what we are passing to get file path to actually read a file that has the .schema.json. Okay, so it reads in the users.schema.json, and once it reads it, it will return me this thing. Okay, so that's for my schema. And for data, okay, now this is going to be interesting. You remember we created a empty data, so now we will say get table file path and then the table name, and this time the file type is going to be data. So you read the users.data.json, and this is currently empty because we have not added anything inside it. Okay, also I hope it has imported it with .js. Yep, that's good. Now let's move ahead. So let's do some quick checks. Number one is if not schema. If someone has accidentally deleted the users.schema.json, then that schema file will not be found. So then we need to do backticks table dollar table name dot schema does not exist. Actually, they don't need to know that the table name schema does not exist. All they need to know is table name does not exist. Okay, throw new error and the same thing. Also, let me put it in this. What were we doing? Double inverted or single inverted? For schema, okay, let's follow it accordingly everywhere. So double inverted, yep, double inverted, does not exist. So if schema does not exist, then we give an error. What about the data? Now this is interesting. Well, currently the data was empty, but we can also do the same actually for the data. Okay, if not data, so actually that can go right here. If not schema or not data, then in that case table name does not exist. So you have to start with the create table query directly. Now what next? We can say const row equals interesting. This would return me an empty array. So I'm not sure. I think that we would get it. This would always throw, but let's check. Const row is a empty object, and now we will say the columns dot for each column. Okay, for each call comma index. If not schema of call, in that case we will log error saying that column double inverted curly brackets double inverted close column call does not exist in table double inverted table name. Okay, so what we are doing here, we so the way to understand it is that for a particular column name, which let's say is the name, okay, you need to go and find the schema for the name in the user schema. So it needs to be txt or text. It should be text, not txt. It should be text, and this int should be integer, uh, or we can keep it int, let's say. uh, Anyways, the idea is that the schema for that particular column should exist in the schema file, in the schema json. If it does not exist, then just throw an error. Okay, that's as simple as it gets. Okay, now hoping that it exists, that in that case we'll say that for the row of that particular column, which is that basically take the key, if the schema of that particular column is actually int. Okay, that's what we saw right now. It was int. So if it is int, then in that case parse int values of that particular index comma radix would be 10, that it's going to be a decimal number, or directly do a values of that index. Okay, so if it is an integer, convert it to a number, else just copy paste that exactly. What this means is that for now boolean actually remains a text. Text would remain a string, that is fine. Int would convert to a number, that is fine. uh, Int would convert to a number, that is fine. Boolean will actually remain a value. So we can, that is another thing that we could fix later. Going to remove all these console logs. uh, so that's our columns, and now we can go data dot push. Remember, it was actually an array. Push the row that was created. Row, based on the row we are creating this, and let me actually console log the data. Clear this out and node test this, and this is what goes inside the data. So inside the data is an array. Inside the array, there is the name of the column colon the value, name of the column colon value, age 22. So do you see the kind of a difference here? This is not a string anymore. This is a string. This is not a string anymore. But boolean is also a string, which is something that we might need to focus and fix later. Okay. Also, what else do we want to focus and fix with? That would be float. Okay. Hmm. So we can actually kind of do that by by adding a switch case or something. I'm going to avoid it for the time being because based on the time that we have, uh, we want to finish the select query today. I want to finish the select query in this session. Right, Jason? That is something that we import. And now we will call the get table file path. It takes in the table name and it takes in the data. Okay. So right, Jason, it needed two things. It needed the file path, which we are going to get because of by using the get table file path, and it needs the data to write, which would actually be this particular variable, which is the data. So till now, you will see that users data is still empty, but after this write JSON, it should uh, be done, and then we will very happily log success, saying row inserted into table name, and wrap it around double inverted, and since I'm very excited and happy, exclamation mark. And let's run this. Insert test passed and row inserted into table users, which is nice. Let's go in here, and there we go. That's our first one. Okay. uh, Now if I go over to my test db, I am actually going to copy this a couple of times. 1, 2, 3, 4, and 5. This is fine. Let's go with Bob, John, Jake. Hmm. Okay, let's call this Tom. And wow, I'm out of names. How is that possible? Uh, MLH. Okay. Uh, 22, 25, 32, false, 28, true, uh, 10, false. I think MLH is like 10 years old now. Okay. And now the insert into 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Perfect. And let me clear this and run this. And 1, 2, 3, 4, 5. Now if I go into this, oh, I did not change the ID. So this is another thing that we are missing. How to make the IDs unique. As you can see, unfortunately, I have the same ID. Okay. Going to delete that. Going to go over to my test DB, and this changes to 1, 2, 3, 4, and 5. Actually, I'm going to go with 101, 102, 103, 104, 105. Okay. Okay, there we go. Created the tables. 101, 2, 3, 4, 5, 5. Somehow I ended up with 5, 5 there. Oops. Perfect. Okay. Uh, yeah, Boolean is something that we can look into maybe later. For now, I think that's our insert into query done. Okay, we can kind of insert data into our database. Okay, which is, I think, awesome for now. The next one and the final one for today's session would be what we had done on uh, SQLBolt, which was the select query. Okay, so let's start with that. So select query, since it's going to be a query, so we'll say selects rows from a table based on a query. Okay, and it takes in the param string query, which is the SQL query to select data. Now we'll say export function select, which takes in a query. Okay, const, we know what we need to do. Match equals query dot match. This needs to be, what does the select query look like? It looks like select and then kind of anything here. Then you have to have a from, and then you define a word here or kind of the table name. So w plus, and then right after that we will say something question mark where. Now where is tricky, so actually I'm going to ignore it for now. From, wait, what did I do? Yeah, select something from this. Okay, let's try this. If not match, then log error. Oh, you have already imported it. Invalid select query. We have not learned about where and stuff, so I'm going to ignore that. uh, Throw new error, uh, invalid select query. um, mm, mhm. Mhm. Okay, let's see. This should be const columns equals match of one. uh okay, match of one dot split it on comma dot map over it, and we'll say for each column you just do a dot trim on it. Okay, we should have kind, like, this is kind of now a repetition of what we are doing. Where would the table name come from? Now the table name actually comes later this time. So select something. So let's go over to our SQL syntax. So select whatever is the column name from the table name. Okay, so the table name comes after the column this time. So match of two and const data. Let's read the data. So now we have the columns and the table name. Let's read the data, which should be read JSON, uh, get table name, get table file path from table name, and the type that we are interested. We don't have to do anything with schema anymore, at least right now. What we want is the data. So we will read the data file. uh, if this is not found, so if not data, in that case we can just do a log error saying that the table name does not exist. Okay, and just copy paste the throw new error and replace the syntax, replace the message, sorry. Now, okay, then the next one is going to be very tricky. I'm thinking. Okay, okay, let's say before we go into the next one, I want to show you something very interesting, which is the new function syntax. So I'm going to create a z.js. What did I create? A jsi. So I'm going to create this z.js. This is to temporarily show you something very quickly. Now, the next syntax that we are going to see or going to use is, if you can avoid it, avoid it. Okay, let me come back on screen. So if you can avoid the syntax, avoid it. Example, so what are we going to use? We are going to use the new function constructor. So I'll give you an example. So suppose you have something like const user input, which is equal to a string of return a plus b semicolon. Okay, this, no, you don't have to copy this. This is for your understanding only. Let me zoom in a bit. So const user input is return a plus b. Now I create a const add is equal to a new function. So I'm creating a variable which is, in turn, is using this new function uh, constructor to create something, and it takes in a comma b comma user input. Okay, it takes in these three things. Now we could do some magic. We can say const result equals this add variable, and it takes in like a few parameters. So I'm going to say it takes in like 5 comma 3. Okay, add takes in 5 comma 3. And now if I do a console log of this result, okay, what would happen? So let's do that. So node space z.js. If I run this, it returns 8. What it did was it took this 5, it replaced the a with like 5, it took this 3, replaced the b with 3, and then because it's a function, it called this user input and it returned this a plus b. Okay, so I hope that makes kind of sense. So you could use this to create new functions and replace variables. What if I do 5 comma 3 comma 5? Okay, in that case it still took the first two. And what if I do 7 3 5? That should return 10. Okay, it took whatever was needed and replaced that. Perfect. Now the syntax, I said this is very dangerous. Why? Because now user, like if someone comes to know that this is what you're using and you're not actually sanitizing your input, they could do something very weird. Let me show you. So the user input is something that the user is giving you. Okay, and this is what I mean by not sanitizing it. So someone can actually do const user input equals return a plus b, which it was supposed to do, at the same time run something else. So like console.log, uh, Okay. And if I remove this one, and now that we have this one, and now if I do console.log result, oh, sorry, this needs to go on top. Mm, do I have a syntax missing? Oh, how can something print after the return? Sorry, my bad there. Yeah. Uh, so this is what can happen. Okay. So someone can actually pass something, uh, and this does not look bad. Frankly, yeah, it's not really hacked as such, but you can do some weird stuff. And in SQL, if you can say that this is kind of an equivalent of SQL injection, where if your input is not sanitized and if you're not exactly checking what is allowed and what isn't allowed, then in that case, you can end up with scenarios where a user tries to parse in some weird things inside. Okay. So console log, and like now anything can happen before the return is what I'm trying to say. Okay. So yeah, so that's a disclaimer that use this new function very sparingly, and also whenever you use it, try and sanitize your input. Okay. So yeah, with that in mind, let's try the next bit. So we have the const data, and now we will say const filtered data. Excuse me. And we will say the actually, what should we do? Hmm, we don't have any conditions right now. So I'm thinking we can actually just return the data. Yeah. Uh, hmm, 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 hmm. Okay. Const result equals filtered data dot map for each row. In this case, if someone has asked for everything, so if columns of 0 is triple equals to star, so if select star is what the query that we are thinking, if that happens, then return the row const selected row equals empty object, and we will say that columns dot for each column return, what am I doing? Yeah, return selected row of column equals row of column. I think that should do it. That should do the trick. And then we can do a return selected row. Let me minimize this a bit, clear the console, minimize a bit, focus on this. Yep, there we go. And then we can just say log success select query executed successfully, and we can actually console dot table the result. Okay, console.table is very specific thing. It actually returns the data in the terminal in a table format, okay, which we will see right now. We go into testdb and let's try to create a third function, which would be called as select. So function test select v1, and inside this our first one would be select query 1, which is going to be select id from users. Then a try catch. Inside the try, we'll call the select with the select query 1. It takes in a query, and going to copy this line, paste it right here, test this, select test passed, or I'm going to copy this over, actually this line over here, test select test failed and the error. And let's call this function right here. So test select v1, clear this, and node space test db.js, and there we go. Okay, so there is an index and there is the id. So now if I actually, and you see that it is in the table format. Okay, so this is the table format that I was talking about. Now id comma name, I want two things. Let's see if we are able to handle that. There we go. So id all caps Alice. I think that's how we saved it. Saved Alice. Yep. So id and name, and let's try the star one. So select query 2, select star from users, and let me call that as well here. Clear this out. Run this, and there we go. Okay, so that's our select query done. We've added a select query and we have tested that it executes successfully. I can try like showing you the errors. So like select star from users 2, that table does not exist. So select test failed. Okay, why? Because file not found. It's trying to find this users2.data.json, and that fails. Okay, perfect. I think this is the perfect time to end the session, so that you can prepare for the next one, which is a origami event. Okay, and you can join Carrie and Quinn in the origami event in the mini events hangout channel. Okay, definitely enjoy that out. Any questions before we end the session? We have added, oh, I need to push this, right? Just remembered. I think, yeah, everything that we have done so far looks good to me. Insert data, select query executed successfully. That is fine. Enter and enter. Insert test passed. Okay, any questions, anyone, before we end the session? I'm going to just quickly do git add, git commit. What did we add? added schema.js and query.js. Also, we added the test db, right? So test underscore db.js, added schema.js, query.js, test underscore db.js. So testing our database, and then git push everything. And for anyone who's just joined or is interested in the code base, there you go. It's on GitHub for everyone to see, use, and work with. Okay, so I think that is my time. Thank you so much, everyone, for joining. Hopefully, you are enjoying the process of creating stuff. Okay, creating a database. Like, remember that when this becomes a library, you can import it in your project, in let's say a Node.js project that you're writing, and then run these queries exactly like SQL. You will call the function select, and then you will pass in like the query. So you'll do a SQL-like syntax thing on the database that you are creating. Okay, so that's what we are aiming for. Okay, and if there are no questions, I think this is the perfect time to end the session. I have a third session and a fourth session. So I have third session today slash tomorrow, depending on the time zone that you think, and a last session on Sunday. Okay, fourth session on Sunday, and by then we would complete all the MVP. Also add some additional functionalities, the to do homework stuff, and that we will add, or at least if we have time, we'll add it. Okay. Anyways, okay, I think that's good. Thank you so much, everyone. Cheers. Enjoy the next mini event. Okay. Bye bye.